Alright, I'm going to help you get started on the last two problems of your homework. The first one, hopefully, you were able to work through just by writing out your variables. Something to keep in mind, especially for number one, if you already did it, was what units does temperature always have to be in? So it always has to be in temperature, so if you forgot to change that, convert it, go back and do that. Okay, so two gases are in a tank that has a volume, so I'm going to start underlining volume of 1 liter and a temperature of 300 Kelvin. The first gas, so I'm just going to go back and circle again, two gases, that's kind of interesting. The first gas is nitrogen gas, underline that, and there are 6 moles of it in the tank. The second gas is oxygen gas, and there are 5 moles of it in the tank. What is the total pressure? Okay, so when I see two gases and I see this word total pressure, I'm asking for the pressure of two different gases. You should start thinking about the law that says that pressure total equals P1 plus P2, and it could go on, but in this case we just have two gases. That's called Dalton's law. So really, if we just added these two pressures together, we could get the total pressure. But do we have the pressure of either of these gases in here? Moles isn't pressure, moles is not pressure, liters, temperature, no. None of these are pressure. So I'm going to split my information up into the two gases. So I know that I have nitrogen, which is N2. I'm going to put some information of this down. The N for that, the moles, is definitely 6. So 6 moles. The other information up here, volume and temperature, I have to think, are these gases in the same tank? And it says they're in a tank, so yeah. So I can put volume as 1 liter, and I can put temperature as 300 Kelvin. Doesn't look like I have any other information. I do know that I want the pressure though, because I'm trying to get P1 plus P2 to get the total pressure. Alright, let's go over to oxygen, which is O2. I know that I have moles, 5 moles, N equals 5 moles. What else do you have for oxygen? So you should see that, like we said before, these are in the same tank, so volume is 1 liter, temperature is 300 Kelvin, and again I want to find the pressure, because I know to get total pressure I could add P1 plus P2, or the pressure of nitrogen plus the pressure of oxygen. So that's a question mark. And so if I want to add this pressure of oxygen, pressure of O2, to the pressure of nitrogen, pressure N2, I need to find these pressures. And so now what you're looking at is you need to do PV equals NRT. Okay, I'm messing this up. NRT to get the pressure here. And then over here, PV equals nRT to get the pressure here. Because you have all this information, N, V, T, P, and then you know R. Same deal over here. So if you can do those two calculations, you can find the pressure of each of these gases. So then how do you find the total pressure? If you can add the pressure of N2 to the pressure of O2, you'll get the total. Okay, so I'm going to leave it there because I think you can do that math. That's just a reminder of how this type of problem is solved. Let's go down to number 3. Alright, so nitrogen gas can be prepared by passing gaseous ammonia over solid copper 2. So we've got ammonia, copper 2 oxide at high temperatures. The other products are solid copper and water vapor. How many moles, okay, so when I see how many, that's the question. How many moles of N2 are formed when 18.1 grams of NH3 is reacted with 90.4 grams of CuO. Okay. What I'm seeing here is I've got a given. How many givens do I have? You have 2 here. 1, 2 givens, and you only have one thing that you're trying to find. So what are you going to have to do? This is the type of problem where you're going to have to set up 2 equations. I'm trying to go from grams of NH3 to find moles N2, and then I'm also given this one, 90.4 grams of CuO, to find again moles of N2. So the question is, why do I have 2 answers that are in the same units, moles of N2? Well, when we react this reactant with this reactant, we don't know which is going to form the less amount of product, the product that will actually be formed. So what we have to do is go through and solve this. I've got grams to moles, so let me put my little box down here. So grams of given goes to moles given goes to moles unknown goes to grams unknown. Okay, so I'm starting at grams of given because this is grams of the given compound, and then I'm trying to go to moles of, and then this isn't given anymore, this must be the unknown, so I'm trying to go to here. So I've got 1, 2 conversions. So I'm going to draw 1, 2 conversions. 1, 2 conversions. Okay, so let's start here. How do you know what units you're going to put down here? Well, you should immediately drag these down. Grams of NH3. This chart can help you, or you can think about it logically. What can we convert grams to? Well, I can go grams of the same substance to moles of the same substance, so moles of given. So I can convert this to moles NH3. Again, I can always drag this unit down here. Okay, so now I've got moles. What can I convert moles of? Well, I could convert moles of NH3 to grams of NH3, but I already did that. That would be useless here. I can go up here and convert moles of NH3 to moles of N2. So I'm going to put moles of N2 here. And so a gram to mole ratio, what kind of numbers go in there? Well, the moles is always going to be 1 because we want to know how many grams are in this 1 mole. And to find the grams, you have to go N, which is 14.01, H, which is 3 times 1.01. You're going to see how slow my math is right now. That's 17.04. The last one is mole to mole ratio. Where do those numbers come from? They come from up here. So I've got 2 moles of NH3 and 1 mole here. Okay, I'm going to let you fill in this last one on your own and do the math. The final thing that you're going to have to do is choose one of these answers. You're going to have to either choose this amount or this amount. How do you know which one to choose? So it should be the lesser, the one that has the smaller number, because that is the one that you can actually form, that won't run out. Alright.